Okay, this week we're looking at colour and we made some secret messages. So if you have a look at our secret message here, if we put the red filter over it, you can see we have a rocket ship heading off to the moon. And this one, it's a lot easier to see that we have the word eyes on it. And the students made their own secret message. This one I think was quite a good one. So it looks a bit like a jumble, but when we put the red filter there, you can see that it says Alex. Okay, we are trying to find out why we see colours. We know that white light is made up of all the different colours of the rainbow. And today we're going to use something called diffraction grating to split up white light. This is a little bit different to the refraction of light by water droplets to make a rainbow, but similar idea. So if we put the diffraction grating here by our light, you can see that the light of the fluorescent tube is split up into all those different colors. And if we look outside, we could again see some of the light outside is split up into all the different colors of the rainbow. So white light is made up of all the Okay, so we know mirrors reflect all the light that bounces off them, but colors reflect some light and absorb some of the light. If we look at a red color, for example, red is absorbing some of the light, but it's reflecting red light back to our eyes. Blue color is reflecting blue light back to our eyes. Okay, now a red filter allows red light to get through. Okay, now why does a green object look black when we put a red filter through it? So green is now looking. Okay, so if you look at this diagram, we have the light. The light is producing all the different frequencies of light, and each frequency is a certain color. So we have the green paper is absorbing all the colors except green. So green light is being sent to our eyes. But if we put a red filter there, a red filter only allows red light through. And because there is no red light coming through, so we see black, which is an absence of color. So back to that. So a light bulb produces white light. White light is made up of all the different colors of the rainbow. This white light hits the green paper. The green paper absorbs all the colors except for green. Green is reflected into our eyes, but it cannot get through that red filter, so we see no light, which is white paper reflects all the light, all the colors, whereas black doesn't reflect any of the colors of light. It absorbs everything. So black is actually not a color, but it's an absence. Okay, now we said that green absorbs many of the colors except for green, and the green light is coming to our eyes. Well, what happens to this absorbed light? Well, if you remember, in climate change, the light that gets absorbed turns to heat. Today we're going to be mixing different colored light using our light box. So we have the green light shining on a piece of white paper. And we're going to open up the red light here. You see we have red light here, green light here, and we have a yellow color in the middle. So red and green make yellow light. Okay, now we're going to be mixing green light and blue. And so I open them up. And there we go. We have a sort of light, sort of greeny blue color. So green light, blue light, and the mixture. And now we're going to add some red light to this mix. And when we've got them all mixed together, in the middle we have, it looks fairly pink. Ideally, if we had the right amount of red, green and blue, we would get a white color, but you can see that it's sort of approaching white. So this in the middle is green, red and blue. Okay, so we've mixed light. Now we're going to mix food coloring, which behaves pretty much the same as paint. We've got red food coloring, and we have blue food coloring, and we get a sort of darker color, sort of purpley brown. We're now going to be mixing green and red. Okay, sort of browny color there. Now I'm going to mix blue and red. We've got slightly darky blue purple color. Now we're now going to mix all three colors, red, green and blue. So, as you say, we got a sort of pretty dark brown color there. So clearly quite a big difference between mixing light and mixing food color. Okay, so why is there a difference between mixing light and mixing food coloring? Let me try and explain here. We know that white light, when it's split up by water droplets, it makes a rainbow. And the rainbow are all the different colors of light. So it makes sense that when we mix all the different colors of light, this goes back to being white light. But what about food coloring? Okay, let's say we have red food coloring. Red food coloring absorbs all the different colors except red, and red is going to your eyes. Blue food coloring will absorb all the different colors except blue, which will then go to your eyes. So theoretically, if the red food coloring absorbs all the colors except red, and we add blue food coloring, and blue food coloring should absorb all the red, then we should end up with no color at all, which is black. Now the blue food red coloring and the red food coloring don't completely absorb, but when we add food colorings together, the more that we add, the more light gets absorbed, and we end up with black, which is no colors being sent to our eyes. So the more colors we add, the more colors are being absorbed, the less light is going to your eye. We end up with a much darker solution. So in art class, you learn about the primary colors, and in art, we have the primary colors are red, yellow, and blue, and these colors can make all the other colors. So for example, we get green from mixing blue and yellow. And then when we mix them all together, we end up with sort of a dark black because all the light is now absorbed. But primary colors of light are actually different. It's also red and blue, but instead of yellow we get green, because green and red will mix to give yellow. And again, when we mix all the primary colors of light, we will end up with white, because we're adding light here. Here we're actually removing light because it's being absorbed. So primary colors of paint or food coloring, primary colors of light.